Hello and welcome. Today we are going to start the first lecture on this very important course called Artificial Intelligence and Machine Learning in Materials Engineering. That's what I said. You are welcome to the course on Artificial Intelligence and Machine Learning. So I welcome you again, and this is an NPTEL course. That means it will be offered on SWAM portal in NPTEL. The full name of the course is Artificial Intelligence and Machine Learning in Materials Engineering. In short form, we can call AIML in Mat Engineering. So we will refer this name very often, the short name very often in this course. First, let us discuss about myself, about the course, about the things which you are going to learn in the next 10 minutes. Then we will talk about it, what is AI and how it is going to change the whole world, as well as how we can integrate machine learning as a part of this course. So my name is Krishan Viswas. I am working as a professor at the Department of Material Science and Engineering at IIT Kanpur, that is Indian Institute of Technology Kanpur. And important thing is my email address that you should note down. That is kbiswas@iitk.ac.in. If you have anything doubtful, anything you need to clarify, or if you want to have some discussions, please use this email address as a mode of communication for this purpose. Otherwise also you can contact me in using phone numbers. So normally this is the internal phone number. You have to add 0512 as a city code for Kanpur, and then you have to add 679 and then 6184. So again I repeat, if you want to contact me by phone, the city code for Kanpur is first 0512, then 679 6184. You can call on this number if you want to contact me, but my main communication with you will be happening through this email address. So please note it down. If you want to know details about myself, please browse my website, which is available. We do work on artificial intelligence, machine learning for last almost 7-8 years. So these lectures will be available online on NPTEL forums. Well, before we begin about any course, first and foremost thing to know what are the objectives of these kind of courses. Because as you know, AIML is a buzzword. So everybody talks about artificial intelligence nowadays, irrespective of branches of science, engineering, and even in literature. So for this particular course, we must know what are the objectives. I list down few of them. First, to know basics of AIML. This is very important. That means this is an introductory level course. This is not an advanced course. This is where you know about some basic aspect of AIML and how to correlate with the design and discovery of new materials. What kind of new materials? New materials with betterment of properties, mechanical, functional, or other properties. So we will discuss about some examples later on in future lectures, where you will see how AIML can be effectively utilized to correlate design and discovery of these kind of new materials. Secondly, it is important to know technological aspects of utility of machine learning in design of materials, because we are engineers, and as a part of engineering we must have good knowledge about technological aspects of using machine learning in design of materials, because design of material is something which is universal. Whether you are designing material for catalytic reaction, designing material for, let's say, something like a brass bar, you need to know how to do that. Using technological aspects, whether we can model it or find the best material using machine learning, that is what will be taught. Thirdly, AIML is a tool, as you know. This is a very important tool nowadays. So how we can use this tool for discovery of new materials? Yes, I am stressing the word discovery, because discovery is something which is very fancy. Discovery means thinking of something out of the box, new, which has never been done, never been thought. So therefore, whether this AI/ML can be used, or the tools of AI/ML can be used for new material discovery. This is something which you will be knowing these aspects. I hope you have understood the objectives. So, at the end of this course, we have to see whether these objectives are satisfied or not, and if not, what are left behind, and if it is so, then whether we can improve further or not. Well, before we start even, we should know also whether do you need some prior requirements or prerequisites for this. So, you need to have some basic idea about material science, that is structure, characterization of materials, mechanical or functional properties. A basic idea. I am not talking about a deep understanding. You need to know that structure means crystal structure, structure means microstructure, structure means some kind of a atomic arrangements in the materials. Also, you need to have some idea about how to characterize these materials, whether we can use X-ray diffraction or we can use some other microscopic technique like SEM or optical microscope to characterize. Similarly, mechanical property like tensile deformations or shear deformations kind of things, functional properties like electrical properties, electronic properties, also many other like functional properties. You should have some basic idea. I am not talking about deep understanding. Some basic idea will help you to make your learning much better. That is something which is required from you. Well, how this course is structured? Let us talk about little bit on these aspects. First 6 lectures will be based on the introductions. Introduction means introduction of AI/ML as well as some basics of material science. That is what I term as basics of materials. I mean to say basics of material science. We will talk about these aspects in 6 lectures. And as you understand, these lectures are divided into 2 parts. Every lecture will have 2 parts, 25 minutes duration, approximately about 25-minute duration, and so therefore, there will be total 12 parts for this section of the lecture. This will be followed by how we can do material design at different length scales. What I mean to say is that if I look at component, let us say I have a watch, this is a component, right, and this component has different parts, and how do I design each of these parts to make this is a useful gadget. So, design starts with the length scale which you see here, that is the meter level or millimeter or centimeter level. Every component will be having certain size. It can be very small, millimeter level, or it can be very big like meter levels, right. So, therefore, we start with that, and can we go down to the atomic level, and we can understand the design principles at different length scale. That will be covered in these 5 lectures. Obviously, I will not be able to do justice, because the design of material at different length scale requires one full course, but we will try to give you important aspects or message how we can actually go through these things. This will be followed by almost 15 lectures on 2 topics, which is the bulk of this course. First, the machine learning approaches, different machine learning approaches for material design. Here we will talking about how machine learning approaches have come through and how they are making used, and then how these machine learning approaches can be used for both material design as well as to accelerate the material development and deployment. See, finally, if I design a new material and make it, I must deploy it upon going through all the stages of material development, then only it is an success story. So, whether machine learning can help us in design, development and deployment, and most importantly whether we can accelerate that machine design and development and deployment aspects using the machine learning. We will be focusing these aspects in this 15 lectures. And as you know, everybody talks about data science, and materials is one of the old field, one of the old fields of research or development. It is almost 5,000 years old. The start of material happens when humans were trying to develop the civilizations, right, that is what. So, initial materials were what available in the mother nature, okay, let us say fur is easily available, and it was used instead of this coat or this kind of shirts, human used fur to protect themselves from the atmospheric temperature or whatever it is. Similarly, human have used also the available metals which are freely available in the earth or the crust of the earth. So, from that time to till today, lot of materials have been discovered. So that means we have huge knowledge on this subject. It's compared to other branches which are coming recently. So that means we have generated a lot of data. So how to manage those data, how to use those data. So there is something called a material data science, or rather I will say material informatics, that is a better term to use. And can you use this material informatics in a way so that we can use this as a mode of making new materials or discovering new materials. So we will not talk about only informatics of materials, but also experiments, how we can accelerate the experiments, how we can develop the new experiments using this kind of informatics. So altogether there will be 40 lectures. That means if I consider each part, there will be 80 parts for these lectures, and you will be given a complete overview of the whole subject, how we can use machine learning, artificial intelligence, machine learning combined, so that you can get an idea about materials design in this course. This is a detailed aspect of the course. First we are introducing the subject, then we will talk about basics of material science, that is processing, structure and property correlations. That is the basic thing in our materials tetrahedron, where we talk about how to make it, and depending on your processing route, structure will be governed by that, and the structure will then govern the properties will govern the performance of any materials. So that is called material tetrahedron. There are 4 pillars of that: processing, structure, property and performance, and that will be taught in this. Then we will talk about, as I told, material design at different length scale. We will talk about different kinds of techniques introduced, how we can do that, from meter level scales to about atomic level, Armstrong level scales. Then we talk about machine learning approaches like compositional property space, how we can design new compositions, new materials, how we can predict the properties, or how we can target the properties. Actually, that is better way to tell you. What I mean to say is that if I want to make a material with some target properties, can I make it, and whether we can use machine learning for that. And accelerating the material development and deployment cycle as well as informatics is going to there. But I will be talking about some case studies from my own research as well as from the research from others, which will acknowledge as a part of this course, and to give you the better perspectives of the course structure. So this is, in a nutshell, is the whole or detailed outline of this course. So what are the books you will be following? Well, 3 books will follow. They are very good books. First one is by Lukman et al. And this book is known as Material Design, Discovery and Design by Means of Data Science and Optimal Learning. This is a Spinger book, and I have a copy of this book. I would like to show you. This is the book. It is not a very thick book. You can see that. So a lot of good things are discussed in this book. Please, if you want to have a copy, you can download. It is available on the internet. You can buy it, or you can use it, or you can have a hard copy also. The next book is by Cheng et al., which is on artificial intelligence for material science. I also have a copy of this book. You can see that this is the artificial intelligence on the machine learning, and this is the material discovery and design. I am showing you these 2 books. So which will be using these 2 books primarily for our purpose. In addition, I have also listed another book. I do not have a copy of this book, but I will show you this book later when I give lecture. This is by Phil De Luna, Accelerated Material Discovery, how we can accelerate the material discovery, and this is published by De Gutierrez. Very recent books, all of these are actually recent. The last one is even hardly 2 years old. So subject is also new, books are new, and you will be learning a lot of new things as a part of this course. Well, let us look at what are the special emphasis we will give. So we are going to talk about design of materials with improved properties, and we will be using AI/ML tools for that. That is our special emphasis on this course. We are going to talk always on these kind of things, how we can design materials with these improved properties. So we will talk about course TS later, because this is something which will come later and we will provide you on the internet. So how we can evaluate? What are the ways of evaluating? First thing is that at the end of this course you will have an online or offline exam depending on the number of candidates taking the exam. If candidate is very large, then we have to go for online exams, and if its number of candidates is less, then we can go for offline exams. Mostly I find online is more preferred. Then weekly assignments which will be uploaded after lectures are uploaded after about a week's tour. At the end of the week rather, the assignments will be uploaded. You will get times about 1 week to solve the problems and to submit online, and there will be minor online quiz also. This is something I am going to introduce, where we can actually do online quiz by very small minor level online quiz to understand whether you are able to understand or grasp the subject matter or not. Okay, that is about the course and details about that. So, now let us move a little bit on details of this course. So, as I said you, this is a course on NPTEL. So, everything will be available on SWAM portal, that is swam.gov.in /NC details by NPTEL, and you have to search this course name AI/ML in engineering. You will find out that, and you will get this course. So, at the end I like to tell you that this is something I get it from the internet. You are going to take a journey on the unknown territory as usual, and the running away from the problems only increase the distance from the solutions. We are here to find solutions of our global problems, each one of us, and that is what is the important thing. So, therefore, it is always easiest to escape from the problem than to solve it. That is what is the human tendencies, but you focus on your subject, you will learn it, and when you embark on an unknown territory, a lot of things which you will learn by yourself. That is something you will do yourself. So, therefore, do not run away or lost in thoughts. This is very important for you. Okay, so first why you need to use AI/ML in materials engineering, and why this data informatics important in material design, why it is so. Let us talk about that. That is what is the introduction. But before that, let me first tell you, what do you think about AI? Everybody talks about artificial intelligence, right? Very simple example of AI is, I can give you my own experience. Suppose I am sitting in my office doing some work, and I have a friend, and we are thinking of going to my home, and once we talk about it, we are going to have some food or drinks, maybe tea or coffee. So, how do I make sure everything is ready at home? No, I am not talking about I call somebody at home and ask somebody some human to prepare. No, I am talking about whether can I use machines to do that. Well, yes, we can do that using your mobile phones. Actually, you can tune your micro oven in your home to make the food hot and ready before you reach the home. That is basically an artificial intelligence. Okay, you are using a tool which is allowing you to make your food ready. This is one way of defining artificial intelligence. AI is basically ability of machines and computers to mimic human mind decision making process. That is what is important. So, human minds are very powerful. We have the abilities to making the decisions, and as well also problem solving capabilities. We can solve many problems. That is why we are here. The society, civilization is here because we have solved many problems. So, here we are talking about it ability of the machines and computers, whether they can mimic this quality of human. Human has the natural intelligence. So, can machines use this as an aspect to learn? And this ability is obviously limited at this moment. There are many reasons for it, but they are limited. With AI, machines can understand your whatever target task you are giving and achieve specific goals. Very simple. If you are giving machine do something, whether the machine can do that job properly and achieve the specific goals or not, that is something which is very important. So, therefore, it is built on two important aspects AI. One is machine learning, other is deep learning. So, if you talk about AI as one block, machine learning and deep learning are parts of that. So, machine learning uses structured data which is structured, which is nicely maintained. Obviously, there are machine learning techniques where one can use unstructured, but mostly they use structured data. Deep learning use unstructured data, some form of a text or images, even you can use images also. That is the difference. So, in a nutshell, machine learning is more widely used because you have structured data, and that is what many of the materials discoveries or material development has provided us, all kinds of structured data, and we can use in this. But in this course I am going to talk about lot of aspects about deep learning at the latter part of this course. So, therefore, there I will teach you how we can use unstructured data, like you can you use a text or images. And ML is basically process by which machine automatically learn from existing data. I hope you understand. In this process, we will be giving the machine data, and machine will learn from the data, and then machine will give us specific goals or achieve specific goals. That is what it is. However, human intervention is still required in this process. It is not that machine can do it themselves, but the ways the scientific discoveries or technical discoveries are going on, one day machine will be able to do with everything without intervention of human. So therefore, let us talk about a little bit more. What is AI? If I say system that can think like human, is it AI? Yes, it is true, correct? Human can also do that, but systems can also do that, they can think like that. System can act like human, do you think so? No, system cannot act like human always, but system can think. System that can think rationally, what about that? Or system that can act irrationally, they are called irrational process. So, for the machine, for AI, first part is called thoughts, the system which can think like a human or they can think rationally also, that is called a thought. Second part, which is actually called a system which can act like a human or which can act rationally, is called behavioral aspects. What I mean to say is that sometimes you think about something before you act, right? You are thinking of going someplace, that is your thought process, that is not actually done at the time beginning. You are thinking only whether I will watch this game or not, I will go this movie or not, you are thinking about it. But then whether your thinking process is rational or not, that is also important. Let us say if I say I will go to the jungle, or I will tell one more example, I go to zoo and I am in the zoo, is sitting and thinking that whether shall I go inside the cage of a tiger or not, that is irrational thinking. Why? Because I may be getting killed by this process. So that is what is, human can always think rationally, but there are a lot of people in the world who think irrationally also, forget about that. But mostly human can think very nicely rationally and they can think also, that is the called thought process. Now once it is thought, once it is done, let us say machine can think like human, although that is not still not achieved to the level to which we can think about it, and whether they can act like that also, like it can act like humans, you can act rational or not. So these are the features AI normally uses. Features which human has, these are the features AI uses. Okay, let us talk about a Turing test, then we will stop. System that can act like human, can I do a Turing test? Art of creating machine that perform functions that require intelligence when performed by people. That is basically taken from Kurzweil. Okay, as you know, this is in inverted commas. And now second is the study of how to make computers think at this moment people are better. Computers do things at this moment people are better, okay, that is from Rich and Knight. So these are the two texts which are going to do Turing tests. So let us do that. So you enter a room which has a computer terminal, you have a fixed period of time to type whatever you want, and then study replies. At the other end of the line, there is either a human being or a computer system. Let us do this experiment, and it is a computer system at the other end of the period. You cannot determine whether it is a system or human, then system is deemed to be intelligent. What I mean to say, you have typed something on the computer and somebody else is there on the other side of the system who is responding to you. Now if at the end of your typing you cannot detect the reply is coming for a system or a human, then system must be intelligent, and it does not matter if the system or a computer or machine or a human. So it clearly tells you that if we can send you replies, that is intelligence system. That is what is a test. So system which can act like a human or natural language, they can do this kind of task actually if they act like a human. First is natural language processing, NLP we call it, to communicate with human. Second is the knowledge representation, that means to store information effectively and efficiently, that is called knowledge representation. Third one is automated reasoning, to retrieve an answer using the stored information, that is what this experiment was that. And last one is the learning, to adapt new circumstances. I hope you understand that. These are the four pillars of understanding what you require. The cognitive task will be natural language processing, knowledge representation, automated reasoning and machine learning. This is the 4 pillars of any AI system. Okay, let us stop here and we will carry over this and this subject in the next lecture also.